This is textbook section 8.1. We're going to talk about some ratios. A ratio is just a comparison of two quantities using division, and that's how they've written it here. But we could also write it like this, A colon B, or write it out as the ratio of A to B. So in our first example, they're telling us triangle XYZ has an area of 25 square inches. The ratio of the base to the height is 2 to 1. So our ratio is right here, and that's base to height. Now we want to find the actual values that are the base and height for this triangle. So 2 to 1 has been reduced. It could have been 4 and 2. It could have been 5 and 2.5. It could have been any combination that got reduced to 2 to 1. So we can imagine before it got reduced, it was really 2 times something and 1 times something, that same something. Anytime we have a ratio, we can slap some x's on it, and now we have variables that we could use to solve for things. So now I know my base is really represented by 2x, and my height is really represented by 1x, and the area of a triangle is 1/2 base times height. So that means the area of 25 equals 1/2 times the base of 2x times the height of 1x. So 25 equals half times 2 is just 1, and x times x is x squared. Take the square root of both sides. X is 5, plus or minus 5, but we don't care about negative right now. So x is 5, meaning my base is 2 times 5. My base is 10 inches. Let's include our units. And my height was just x, so my height is 5 inches. So there's a try problem here for you with a rectangle. You could pause if you'd like. Answers are posted online. An extended ratio is when you want to compare more than two numbers, so 3 or more. We'll often use this with angles in a figure or sides of a figure, but it could really be used for anything. Just anything that could be broken down into pieces that are not necessarily equal. So for example, 2, the ratio of the measures of the sides of a triangle is 5 to 12 to 13, and the perimeter is 120 centimeters. Find the measure of each side. So just like before, I'm going to slap some x's on these. Instead of 5, 12, and 13, it's really 5x, 12x, and 13x. And when you're talking about the perimeter of an item, we would be adding them up and setting it equal to that value. So we're going to have 5x plus 12x plus 13x equals the perimeter, which was 120. So this is 30x equals 120. So x is 4. And now if I put it back into each of these, 5 times 4 is 20, and our units are centimeters. 12 times 4 is 48, and 13 times 4 is 52. So those are the side lengths of my triangle. So for try 2, you're dealing with the angles of a triangle. Pause if you'd like. Answers are posted online. A proportion. We've mentioned the word proportional. A proportion is basically two equal ratios. We don't really care about the names that they call these the extremes or the means, but we do know the cross product property applies, which means you can cross multiply here or do the butterfly method. The product of the extremes is equal to the product of the means, right? And that's our butterfly. So let's practice some of that butterfly. When I'm cross multiplying, if I have more than one term here, right, x plus or minus something, I'm going to stick that inside parentheses, because when I go to cross multiply, I'm doing 9 times all of x minus 1, and I'm doing 7 times all of x plus 4. And I have to make sure I'm distributing, and I might forget to do that if I did not include parentheses. So I have my 9x minus 9 equals 7x plus 28. I could take away 7x. I can add 9. And then when I divide 37 by 2, I get 18.5. It's perfectly fine to have decimal answers for x when you're cross multiplying something. Much of this chapter will be decimals. We're not going to have a lot of nice answers. So here's one for you to try. Pause if you'd like. Answers are posted online. So here's the real part of section 8.1, and that is similarity. We have been dealing so far with congruency, when two geometric objects were exactly the same size and shape. But once we introduce dilations, now we're talking about figures that are similar. They're the same shape, but not necessarily the same size. So the corresponding angles are congruent, but the sides are proportional. And the symbol for similar looks like the squiggle that was above the congruent sign, but without the equals, because they're no longer exactly the same. They lost their equals. Just like with congruency, we have similarity statements, just like we had a congruent statement, and we're going to match up the letters and the sides the same way we would have when it was congruent. So we have to make sure that the corresponding angles go together, and then all of the sides will be in the same ratio, and they showed here 15 over 5 turned into 3 over 1, 12 over 4 turned into 3 over 1, 21 over 7 turned into 3 over 1, 18 over 6 turned into 3 over 1. So what that tells me is we still have something called the scale factor in our similar figures, just like we did with our dilations. We're still going to use new over old. I will say it gets very tricky, scale factor, with just similar figures, because some books teach it the reverse way and some do not. And you're just going to have to give your best guess as to how they're asking for it on most things. But the way that makes the most sense is, how did you get from the old figure to the new figure? How much bigger or smaller did it get? So the scale factor still makes the most sense to do new length over old length. So here the triangles are similar. They're giving me a similarity statement. They want to know what is the scale factor. Both of these questions ask the exact same thing. The only difference is they have reversed the order of the similarity statement. So what that means is, in part A, they're treating triangle ABC as the old one and triangle XYZ as the new one, meaning it was a reduction to get from ABC to XYZ, which means my scale factor should be less than 1 if it was a reduction. So if I take 3 and put it over 6, I really get 1/2 as my scale factor for when ABC is similar to XYZ. But if I flip the order around, I'm now considering XYZ the original and ABC the image. So that means I'm getting bigger to get from XYZ to ABC. So the 6 would go over the 3, and then my scale factor is really 2 over 1, or 2, but I would keep it as 2 over 1. In example 5, they're telling me they're similar, and they're telling me what sides go together by giving me the similarity statement. What I would do here is DE is in the same spot as MN, so on the side that's DE and the side that's MN, I'm going to mark them in the same way. EF and NP. EF is here, NP is here. I'm going to mark them in the same way, and then my third sides would match up as well. If I want to solve for x, I know I'm going to have to compare the side that has an x to the side that has a 30. They're not equal because they're not congruent, but I'm going to set up a proportion comparing x with 30 and then another pair of corresponding sides. Let's call it the 15 and the 18. I have to be careful. If I chose x to go on top of my first fraction, then the same 15 from that picture has to also go on top. I just have to be consistent. So when we cross multiply here, we're going to get 18 times x and 30 times 15. And then I'm going to divide by 18, and I get 25. If there was a different variable in this picture, let's say we also had a y here, then I would have done exactly what I did to solve for x, and then I would have kept 15 over 18 and 20 over y to find the other variable. So that's what you're going to do in this one. There are 2 variables to solve for. Pause if you'd like. Answers are posted online. In example 6, we are given the fact that the 2 triangles are similar, but now they want me to find the length of altitude. Altitude's another word for the height, the altitude PS. So that's not a side of my triangle, it's actually inside the triangle. But what's very nifty is that when triangles are similar, any of the special segments that could have appeared in them would also have the same scale factor or be in the same ratio as the sides are. So the altitudes, if they had perpendicular bisectors, if they had angle bisectors, or another segment called the median, all of those would apply to be similar the same way the sides are. So let's call this here our variable. There we go. So I can compare a side to a side, 12 to 16, and then the height to the height, x to 20. So that's going to be 16x equals 240. Oops. Trying to use my calculator. And I get x is 15. So the height or the altitude of that triangle is 15. The last thing we're going to talk about is the ratio of the perimeters of two figures. If the shapes themselves are similar, then whatever that scale factor is the same as the ratio of the perimeters. So adding up the sides and comparing them will reduce to the same fraction as comparing a single side and reducing it. This is by far the easiest thing to help us remember something, to help us find the perimeter, and it is often the most forgotten thing to do. We just revert back to finding every side and trying to add them up, but I will tell you that is not beneficial because sometimes the sides don't come out to be really nice numbers, and then you're rounding, and your answer is going to be different than what it should have been if you used this theorem, property, whatever you want to call it. So here, for example 7, we have a pair of similar shapes. We want the scale factor of MNPQ to XYZW. So this is old, and this is new, and then the perimeter of each polygon. I could right away find the perimeter of this one, right? If I add 9, 8, 7, and 10, 9 plus 8 plus 7 plus 10, I get 34. So the perimeter of MNPQ is 34. That one's done. For scale factor, I know I'm going to compare the only side I know in this one, which was WX, with the corresponding side MQ. So new over old, 4 over 8, the scale factor would be 1/2. So what I'm going to do now to find the perimeter of my new shape, if I know new over old was 1 over 2, the new perimeter will go over the old perimeter as P over 34. So if I cross multiply this, I'm going to call it P of XYZW, and that equals 17. So this is the last problem for you to try. Pause if you'd like, or end it. The answers are posted online. But that is the end of section 8.1.